potentials and the challenges in the global context. So before I start with explaining you all about the carbon capture and storage, I would like to say a few words about IEA Greenhouse Gas R&D program. IEA Greenhouse Gas is a collaborative research program which was founded in 1991, and we have implementing an agreement with International Energy Agency IEA in Paris. And our aim is to provide the members with the definitive information on how the different technologies can participate in reducing greenhouse gas emissions. Our work is very important and is very trustworthy because we do a peer review of external experts of whatever technical evaluation we are doing. So it is not biased, it's very independent. And we are not policy prescriptive. We try to give the sufficient information. So we try to draw their line there that we are not giving any policy prescription to the policymakers. And how does we work? Is that we have members and sponsors, and they all participate in the common fund. And to finance our activities, our main activity is to do the technical evaluation of different technologies for greenhouse gas emission. We also do dissemination of information, so such as we organize big conferences, and we have also small conferences and networks. And we also do educatory work, which is our international summer school, which is every year to educate the young generation about carbon capture and storage. So our activities, as I said earlier, our main activities are technical studies, and so far we have published more than 250 studies, and they are freely available from our website, so if you're interested, please download from there. And besides that, we also do the international collaboration and information dissemination, and part of that is one of our main greenhouse gas technology conference is GATT. It's every 2 years, and next year it will take place in Texas, so I would like to invite you all to go there. It's very interesting, and it's a very big conference. And besides that, we have other two small conferences. First one is Oxy-Fuel Combustion Capture Conference. This year it took place in Spain in September, and the second one is Post-Combustion Capture Conference, and that took place as well in September in Norway. We have other networks related to the CCS, and also we do different workshops, and such as we have high temperature looping workshop, and also different topics for CO2 storage. We have different workshops there. As I mentioned earlier, we have International Summer School as well, and that is open for all the international students. We have every year like 56 more or less students from all around the world, also from India and China and all Asian countries. The other part of our work is to support the implementation of the CCS, so we provide the policymakers and regulators all the sufficient information, and we also collaborate with the relevant organizations to develop CCS knowledge and different projects. This is a slide just to show you the members which we have. So you can see we have our members from different countries all around the world, Asian countries, and India is also a member, and we are very happy about that. And you can see our sponsors, they are from different areas of industry. So we have from oil and gas industry, like BP, Shell, Chevron, and we have energy industry and technology suppliers, and we have a partner organization like Japan Coal Energy and TGRC from Canada and Carbon Sequestration Leadership Forum. So we have a quite nice mix of all the members and sponsors, so we have a very good support and information. Okay, so now starting from the CO2 capture, before I start explaining CCS, I just wanted to show you some of the facts and figures. So this is graph taken from the Global Environment Association, and you can see that in the first graph how the atmospheric CO2 is increasing, and you can see over the years the atmospheric CO2 is increasing, and is now we are at the 400 ppm level of the CO2 concentration in the atmosphere, and that means that we are reaching very steeply to the increase of around 6 degrees by 250 as it is projected by IEA in Paris. And what is this concentration will impact to the environment? So you can see how the global temperature is rising, and over several years there is almost already a 1 degree centigrade increase of temperature of the surface, and that means that our global sea level is also rising. You can see in this graph here, and also because ocean water can absorb CO2, so ocean is absorbing CO2, and because CO2 is an acid, so it's getting more and more. The pH of the sea is also decreasing, so it's getting more acid. That's affecting our environment. So that's very important for the environment point of view as well. So you can see from all these facts and figures that there is increased demand to do take some measures to reduce the CO2 concentration for the environment. For the CO2 emission, here is the graph showing over the years how the CO2 emission has been projected by different countries, and you can see there has been a lot of increase in the over the years, and from 1900 and especially from 1990 till 2012, there's been quite a change in shift in the CO2 emission from different countries, and you can see that by 2012, India became the third largest CO2 emitter here. So that shows that there is quite increased demand to take some measures reducing the CO2 emission, and these projections are from energy-related CO2 emissions. So just to explain, I think most of you are familiar with this figure, but I just put it if you are new to this area. So the carbon capture and storage. So how does it work? We have the different emission sources of CO2. So that is here. So different industries, energy generations, and so you can capture the CO2 from all these different emission sources. And the captured CO2 can be transported by different means, such as pipeline or ship or by road or by rail. So then the captured CO2 is transported, and then this transported CO2 can be sent to either for the storage or for utilization. So storage can be done in saline aquifer or in depleted oil and gas fields. So this is basically an overview of how the carbon capture and storage works. And now next part is to explain just to give you a brief idea about different technologies. And here is just a schematic picture of how the three main technologies for carbon captures are. So the first one is the post-combustion capture technology. Here the fossil fuel is burned to produce electricity and heat, and then the flue gas containing the CO2 is sent to the capture unit, and where the CO2 is separated from the flue gas, and the treated gas with the reduced CO2 is sent to the atmosphere, where the captured CO2 is sent for further compression and for transportation. The second technology is the pre-combustion capture, IGCC, as you have heard from the last speaker from yesterday's session. So the fossil fuel is gasified, and it is sent to the water gas shift reaction, and where the CO2 is sent for the Syngas stands for the CO2 separation, and the CO2 is separated CO2 is sent for further CO2 compression and dehydration, and produced hydrogen is sent for power and generation. The third technology is the oxy-fuel combustion capture. First, the fossil fuel is burned in the presence of pure oxygen, almost pure, and that creates a very concentrated, high concentration CO2 in the flue gas, and which will further only require a compression and dehydration, and can be sent for transportation. So these are the three main technologies for CO2 capture available. So why do we need CCS? As you have seen the facts and figures, and you have also seen how the India is increasing CO2 emission. So here is a projection from the IEA on different scenarios. So in this graph, you see the emission reduction in gigaton of CO2. And if we don't do anything right now, so we will end up increasing our temperature to 6 degrees centigrade. So that you can see on the top that the projection is going upwards. So with the current state of the policy and development, we will end up having 6 degrees centigrade increase in our in the environment. If we are placing proper policies and CO2 capture technologies application in the industry and in power generation, we will have another scenario which will reduce the CO2 emission, and our global temperature will rise only 2 degrees centigrade by 2050. So as you can see, to reach this 2 degrees centigrade scenario, there are different aspects for the power generation. So by applying nuclear, it will contribute to 8% in reduction, and for power generation efficiency and fuel switching is 3%. Renewables energy is participating 21% reduction in our CO2 emission, and CCS will participate to 14% for the CO2 emission reduction, and as well as the end-use fuel and electricity efficiency is the major part for the emission reduction, which is 42%. So from this portfolio, you can see that, of course, it's very important to have different improved efficiencies and different technologies for the power generation, but CCS will play also an important role if you want to reach our goal of only 2 degrees centigrade increase by 2050. So this shows that CCS is also very important besides all the improvements and different generation, electricity generation technologies. This is another evaluation, and this is also from IEA in Paris. And here they have evaluated 80 different regions and sectors for their CO2 emission reduction. So here you see the number of sectors and regions here. So they evaluated 80, and here is the cumulative mass captured between 2015 to 2020 gigatons of CO2. So you can see that if we do capture on all these regions and sectors, we can reach to the half of the total CO2 reduction, which that's the goal to reach 2050. And so from these top 10 sectors and regions, you can see there are different sectors such as power from coal in China, power and coal in OECD in Americas, and power and coal in OECD in Europe, and as well as power and coal in India. That's also in the top 10 list for the IEA evaluation. So that shows that India is also in a quite important place to put an effort in reducing CO2 emission to reach the global reduction of CO2. So here are some key findings from the carbon capture and storage roadmap for 2030 from IEA Paris. and it shows that CCS is very critical if you want to reduce the CO2 emission by between 2015 and 2050. The largest challenge, because there has been a lot of pilot plants, evaluation on different sites of capture on different technologies, on transport and storage. So it's very important right now at this stage that we have a whole integrated chain. So we have a complete chain of CCS demonstration projects. And this incentive framework evaluated by IDA shows that we need at least 30 operating CCS projects by 2020. And if you want CCS to be applied completely, it's not only for electricity generation, it's also for industrial application, because they are also playing an important role in CO2 emission, and they can be very good for CO2 reduction as well. And so for the non-OECD countries, China alone can account for 1/3 of the global CO2 emission, and if you place that, then it can be reduced between 2015 to 2050. And so this shows that there is an urgent need to put an effort in the CCS deployment, and this decade is very critical for us to develop these different projects, to develop the understanding and develop these favorable conditions for long-term CCS deployment. Now I would like to show you some projects which has been running for several years on the CO2 capture and storage. So here you can see in this graph over the years different projects on different areas, so such as gas processing, chemicals, refining, biofuels, iron, steel, and electricity generation. So you can see here initially the CO2 capture started from the gas processing such as the Seisner in Norway and Schild Creek and Valverde in USA in 1972. That's very long time ago. And in around 2004 in Salah in Algeria, they are doing CO2 capture and underground storage without EOR. And it has been done very successfully, and it's a lot of learning points from that project. And in 2008 in Norway, they also started CO2 injection for CO2 storage, and so on. So you can see that there are different projects over the years in natural gas processing, as well as there are some projects from the refining area, such as the Great Plains Vapor, where CO2 is injected for the EO enhanced oil recovery application, and Port Arthur, that's for the in USA in refinery, that's for CO2 to be stored. So these are the past activities for the CO2 capture and storage. Here, now you can see what are the upcoming and the planned or are the construction stage projects. So you can see here different projects, especially in the power sector, so such as Boundary Dam in Canada, that's a post-combustion capture on a coal-fired power plant, and their CO2 will be sent for the enhanced oil recovery. The capture CO2 road project in the Netherlands, that will be also on the coal-fired power plant, and that CO2 will be sent to the depleted gas field in the North Sea. And this project is a road project is at the planning phase, and the Boundary Dam will start in operation next year in spring. So that's very important for us to see all these projects moving forward, as well as from different industries such as iron and steel, the Masdar collaboration in the UAE. They are starting this very nice project on CCS doing capture CO2, putting it for EOR application. And so you can see here there is a wide variety of different projects coming up from different areas, and also from the power generation, from post-combustion, and also from ITCC in USA, such as Camper, TCEP. So these are very important projects which are being planned and hopefully they're going forward. So this is just to show you how the projects are moving forward around the globe. And this is more on the capture side. So you can see here similar projects over the years and how on the different capture technologies and also on the size of CO2 that will be captured from the 1 million tons of CO2 per year to 2 to 3 million tons. So this shows that there's a lot of activities going on around the world, and there's a different scale of CO2 capture. So this is quite a promising picture. So when we look at the approach which has been taken by different regions, so there has been different approaches. So I just took an example for Europe and America. So in Europe, we have developed a portfolio in which, in 2007, in which 12 demonstration projects were planned. And in 2009, they have launched the directive for CCS, and there are the different financial incentives, such as European Trading System and NER 300 to do the financing for different projects. The demonstration funding set was also set aside by European funding for in 2009, and there is one project which is still operating from this funding. And for the NER 300, this year they had a second call for project submission, and the UK they have submitted one project for the funding. And so far there is no demonstration project from European Union yet, but it's still in progress. And there has been a lot of effort from UK to have some demo projects, and from Netherlands and Norway they are also putting an effort in having some more demo projects. Whereas if you look at the America, in 2003 they announced the Future Gen, which is the oxy-fuel technology CO2 capture project. And they have a regional carbon sequestration program which started from 2003 and it's going on. And they have 4 different projects for 1 million tons of CO2 which is injected. It's underway. And they have developed from their Energy Recovery Act in 2009. They have started one industry demo project and 4 power generation demo projects. And from Future Gen, their second phase also was funded in 2009. And the U.S. Environment Protection Agency started this CO2 injection rule. So they have developed these guidelines for the CO2 injection, which was announced in 2010. So you can see that there are different, slightly different approaches from different regions. But yeah, things are moving forward, so that's quite the positive side. Here, this figure is just to show you the geographic distribution of different projects, more from the storage perspective. So, for example, you can see here in Saudi from Masdar, they have this CO2 injection for EOR application. In China, they have this Canadian, combined with Canada government and China, a funded project for enhanced coal-back methane recovery. And also in Japan, they also have those. And in Australia, they have this on the coastline. They have a project which is capturing, taking CO2 from different industries, so such as aluminium, urea, power generation. So that's quite an interesting project to show how CO2 capture and storage can work at an industrial location, and as well as there are different projects such as in the Netherlands. We have a K12B storage site on North Sea in the depleted gas field. And in France, there is a Total Love project where they are storing CO2 in the depleted natural gas field. And in Canada, they also have enhanced coal bed methane recovery, and as well as in US. And in the US and New Mexico, they have a project on sandstone CO2 storage. So this shows that there has been a variety of projects which has been done in past and currently going on different side of CO2 storage as well, and different type of storage options. So this shows that there is quite a knowledge development in this area as well. So for the role of the carbon capture and storage pilots, it's very important to have these different pilots at different regions running. And so far there has been different technologies evaluated, but there is still a need to do more of these injection pilots, as that will develop more confidence in the carbon capture and storage. From these pilots, besides that, there is also important to develop the knowledge base, such as from the journal, the conference proceedings. The American Association of Petroleum Geologists and European Geoscience Union, they are doing a lot of effort in the CO2 storage side. And the second aspect is also these pilots, when we do these demonstration projects, that will also develop the public confidence on the CCS, and then you can have all these exhibitions and interaction with the public to explain, look, this is how the project works, and these are the results, and this is how we can reduce CO2 emission in a sustainable way. And there is also important for the demonstration implementations, so such as K12B, as I mentioned earlier, it's allowed for the CO2 storage, which will be coming, CO2 is coming from the road project from the Netherlands, coal-fired power plant. And there is also a need to develop the expertise for the larger scale implementation. So we need to develop the knowledge base, and I think this is a very good activity today to disseminate all the information to the very intelligent engineers in India and all the contractors and equipment suppliers. So we also need to put an effort in developing knowledge in that side as well. So where are we now? So all these efforts are going on around the world, and there is a different focus which has been shifting, depends on how the industry is. So far, as you can see, that the CCS basically started in the gas supply industry, and as in coming 2 decades, European energy generation will shift more to the gas-fired power plants. So there is an increased interest in CCS on gas-fired power plants. And for the US, the Environmental Protection Agency will put more regulation on the coal-fired power plants for the CCS application. And in Norway, they had a plan for the most advanced gas-fired CCS demo project. And this year they have put a hold on the full-scale demonstration in the Mongstad refinery in Norway. But they are putting an effort in developing different projects and continuing more and more research on CO2 technology development. For the UK, we have the call for the 5 megawatt pilot plant from Energy Technologies Institute. So there are activities which are coming up, and from the Department of Climate Change, deck. They have a second round for Peterhead gas-fired CO2 capture plant. So that is moving forward. So we are very optimistic, and you can see that there is a lot of effort from the government coming up to implement CCS and show how this can be done in a whole integrated chain of CCS. So that's for the power generation. Now I would like to give you some information on the industry application for CCS. And in this is a figure from IEA. And you can see that here in the gigatons of CO2 emission in 2010 from different industries such as aluminium, pulp and paper, natural gas processing, refining, chemicals, cement, iron and steel. And you can see here that the major emitters for CO2 from industry are iron, steel, cement and chemicals and refining. And for these industries, they are putting a lot of effort in improving the process efficiency and doing the more design change to reduce CO2 emission. But you can see that still CCS will play a very important role if you want to reduce a large amount of CO2. So for the industries, it's very important to have CCS demo projects to develop better understanding how this works on the industrial side. So there are some examples here for CCS research from the steel industry, and this ULCOS, ultra-low carbon emission project, which is a consortium of different steel industries and also government. They are developing an oxy blast furnace with top gas recycle and capture. In Japan, they also have this CO2 reduction project on steel is called Forest 50, and this is a demonstration project for post-combustion capture from blast furnace, and it's a 30 tons per day pilot scale. In Korea, they are also doing demonstration for ammonia scrubbing of blast furnace gas, and this pilot plant is at the first stage of the testing. So this shows that the industry is also putting an effort in developing a better understanding of CO2 capture technologies and their integration in their plant. From the iron and steel sector, we have published our technical report. We are the first one who has done this to an extensive study, and it's the first independent assessment for CCS integration in a steel plant. And this was done together with Svera and BFOS and Swedish Energy Agency. And what was the outcome is that the oxy blast furnace was the technology found to be most suitable for reducing the CO2 emission from the blast furnace. And so there is a technical feasibility that needs to be evaluated even further because every plant is different. And but it's very important to do this integration of the CO2 capture technology in these plants because that's very important. And the other non-technical issues concerned are the how these industry when they have CO2 capture plant, how competitive they will be. So just a quick information on the cement industry. Here are different projects from European Cement Research Association. They're doing oxy-firing on cement kiln in 2013. They're starting that. And in Norway and European Cement Research Association, the pilot scale on cement kiln is also starting up. In Taiwan, they're also starting a different technology, calcium looping pilot plant in 2013. So that's also very important project. So where are we right now? So we are basically currently looking at all these different large-scale CCS demo projects, and Boundary Dam in Canada, which is starting next year, is very important for that. And once we have done that, the next step will be to learn from these demonstration projects, and also the industry demonstration projects is also very important. And maybe we have to put a bit more effort because the climate is changing very rapidly. And but yeah, technology is moving forward. There has been a longer time for other technologies, but it's very important to keep on moving and not to stop. So that's very important. And so what are we expecting next? So, and what we need to do is, first thing, that we need to have more pilot plant activities in the global different regions. And we also need the demonstration projects from the industrial sector, and especially from China. And we also need to have more activities on the storage side, and that will develop more confidence for this CO2 storage and understanding. Okay, so that was my talk on CCS, and I just want to bring your attention for the Greenhouse Gas Technology Conference, which is next year in October 5th to 9th of 9th October in Austin, Texas, and the call for paper is open, so the deadline is 10th of January. So please, if you have interesting results, please submit that, or otherwise please go there to attend. It's a very useful conference. And from that, I would like to say thank you everyone for your attention, and yes, I'm really happy to have it.